Assalamualaikum. My name is Ahmad Nifan bin Muhammad Jamadi. I am the leader of the case study 12. So this is my team member Muhammad Akmal Idalan bin Hisamuddin, Muhammad Haris Afzan bin Zulkifli, and Mikael bin Kamal Bahrim. So my team need to design, set up and configure the hybrid LAN which are wired and wireless LAN for SAFA Health Management Sdn Bhd. So let's get started. Introduction. The situation given is where hybrid LAN, wired and wireless LAN is created for two floors for SAFA Health Management Sdn Bhd. The first floor consists of 15 PC while the second floor has 15 laptop and 10 mobile. All staff device, laptop and PC must be connected to a web server by using a switch. Connection between devices has to be cable at first floor, which means the connection are wired, while the connection at second floor must be wireless. This report represents a network topology design along with valid reason for picking said design. There is also a LAN concept design using a packet tracer, a visual simulation tools that allow users to create network topologies and modern computer network, and recommended type of cable that is suitable in terms of cost, strength and weaknesses in order to connect the first floor and the second floor of SAFA Health Management Sdn Bhd.
For physical structure, we'll be using Cisco Packet Tracer to plan our network layout. For first floor, there will be 15 computers that connected to a switch by using a UTP cable. Then, the switch is connected to a router on the first floor by using also a UTP cable. For a second floor, there will be total of 25 devices that connected to a access point. There will be 15 laptop and 10 smartphone that connected to the access point. The access point then connected to a switch on the second floor by using a UTP cable. The switch on the second floor also connected to the SAFA management server, which are web server, DNS server, and DHCP server. DHCP server are responsible for assigning each of the device of their own IP address. The DNS server is responsible for giving a name to the IP address for the SAFA management, and web server is responsible for storing web information of the SAFA management. After all the device is connected, we test the connection between the device by sending a data. For this demonstration, we'll be sending a message from PC3 to a laptop on the second floor, which is laptop 10. The message is went to the switch on the first floor and then to the router. From the router, it makes its way to the switch of the second floor. And then the message went to the access point on the second floor and be given to the laptop 10 on the second floor. After a while, laptop 10 give back a response to the PC3. The data go through from access point to the switch on the second floor, then to the router on the first floor, then to a switch on the first floor, and back to the PC3. Apart from sending data to test the connection, we also test the connection between the device by using a ping command. We ping PC4 on the first floor to the smartphone on the second floor, and As for the result, 4 packet of data being sent and 4 packet of data being received, thus making the connection is secure. After the connection between the device is secure, we also check whether the device can access the SAFA web management. As we can see, we pick a random laptop on the second floor to access the SAFA Health Management web, thus making the connection between the laptop to the server established successfully.
Now I'm gonna present the network topology diagram. Okay, the first one is star topology. Okay, as we can see here, all the PC is connected with the hub. Okay, each nodes or each PC is connected with one hub. Okay, the network topology that was used in this project is star topology. A star topology is a topology for local area network LAN in which all nodes are individually connected to a central connection point, like a hub or a switch. A star takes more cable than a bus topology, but the benefit is that if a cable fails, one only node will be brought down. The reason why we choose the star topology is because of its characteristic, which is high speed, very flexible, high reliability, and high maintainability. Besides that, the advantage of the star topology are easy to manage and maintain the network because each node requires separate cable. Easy detect problem because cable failure only affect a single user. Fault identification and removing nodes in a network is easy and provides very high speed of data transfer. The next one is transmission media. Okay, we have three picture in here. The first one we can see wireless network interface card, which is WNIC. We usually use or see this one because we're using as a Wi-Fi or Unify, something like that. And the second one is a connector, RJ45. This usually used in the in the building or in the office. And the third one in unshielded twisted pair cable. Okay, the third one is network and connecting device. Okay, this is a type of network and connecting device. Okay, the first one is network switch. This we usually use like a star topology connected with the one hub only or switch. This is the example of the star topology. And the second one is access point, which is same like a router, the third one, as like a wireless network interface card, which is WNIC. And the fourth one is a server. Server is connected with all the LAN user, but the server is the biggest one. This is the main one for all the internet network.
Next, we will go to detailed costs of implementation. First, we will go to network device and cabling costing. There is 4 device of network device and cabling that we need in this project. First is cable, which is UTP SCAT623U ProLink cable, which is the price is 288 ringgit. We need the 2 units, which is amount 576 ringgit. Next, we have router, which is RM 245 unit, which is we need 1 unit only. Switch 2 unit, which is amount 2,218 ringgit and 1998 cent. And last we need access point, which is we need only 1 unit, which with price RM 924 ringgit with 12 cent. Next, we go to hardware requirement and specification. For hardware, we need server and storage. For server, we need 3 unit, which is amount 22,236 ringgit and 87 cent. Storage, we need 5 unit, which is amount 1,305 ringgit only. Lastly, we have software requirement and specification. In our project, we need Cisco Packet Tracer to design our network model. Packet Tracer is a cross-platform user simulation tool designed by Cisco system that allow users to create network topologies and imitate modern computer network. The software allows users to simulate the configuration of Cisco router and switch using a simulated command line interface.
Strength. First, cost effective. Compared to the shielded twisted pair cable, which is a STP cable, UTP is much cheaper as it requires less material to form a cable. In addition, STP cable need more special material to make it more expensive. Second, low maintenance. There are lesser possibilities for the cable to break as there is no foil and grounding cable. This architecture helps reduce the need in finding any small tears in the foil. Therefore, UTP cables require less maintenance services. So for the third one, network topology's advantage. It is a very reliable. For example, if one cable or device fails, the others will still be able to work perfectly. Second one, it is very high performing as no data collision can occur. So for the third, less expensive because each device only need one I/O port and wishes to be connected with hub and one link. For the fourth, it's easier to put in. And there are others which are robust in nature and easy fault detection because the links are often easily identified. Weaknesses. UTP cables are more prone to electromagnetic interference and radio frequency interference that is caused by a microwave. So they are more susceptible to electric noise and interference compared to other forms of cables. For this reason, they should be kept out of the wave range of electric motor and fluorescent lighting. Second one, maximum length. It is known that UTP cables use copper cables, so the limit is maximum length to only 100 meter. If the cable exceeds 100 meter, it will get too much signal loss due to high cable temperature. For the third one, network topology's disadvantage. It is requires more cable than a linear bus. Second one, if the connected network device, network switch fail, non-attached are disabled and can participate in network communication. Third one and last one, more expensive than linear bus topology due to the value of connecting devices, which is network switches. Project recommendation. So for the project recommendation, in the future, my team thinks there are several ways to improve the network structure by increasing the speed of data transmission or reducing maintenance costs. We plan to change the connection type as well as the type topological infrastructure that is easier to maintain and cost effective. So for the connection type, we prefer wired connection than wireless connection. In general, the cost of implementing a wireless network is relatively expensive. It's because your network requires additional equipment such as a wireless repeater or a commercial grade router. Wireless repeater increase signal strength and commercial grade router, which provide more reliable connection and improve security controls. Wired networks are generally much faster than wireless network. Data speed has continually improved with the inception of gigabit router and other new technologies. Additionally, wired networks tend to be void of any dead spot that are occasionally present in a wireless connection. This is mainly because as a separate cable is used to connect each device to the network, with each cable transmitting data at the same speed. So for the network topologies, my team recommend to change the design from star topologies to bus topologies. This is because bus topologies requires less cable length than a star topology. Bus topology also easy to connect computer and peripheral to a linear bus. So we recognize when we use bus topologies, we can cut maintenance costs and also can increase the speed of transmission data.